Hi guys, today we are going to be looking at sine, cosine and area rule in 2D numerical trigonometry. Let's start. There are four basic requirements that you can use to solve triangles. The first one is 3 trig ratios. The second one is the cosine rule. The third one is the sine rule. And the fourth one is the area rule. There are 3 trig ratios. Do you remember what they are? Do you remember the phrase soccer tour? Soccer tour, we look at the 3 main ratios that we deal with. So we have sine of theta, which is equal to y over r, which is equal to opposite over hypotenuse. We have cos of theta, which is equal to x over r, which is also equal to adjacent over hypotenuse. And we have tan of theta, which is equal to y over x, which is equal to opposite over adjacent. Number 2, the cosine rule. We use the cosine rule if we know 2 sides and the included angle, or 3 sides of the triangle. In any triangle ABC, if we are working out the side of a triangle, we use the formula a squared is equal to b squared plus c squared minus 2bc times cos of a. What's important to remember here is the small letters or the lowercase letters represent the sides, whereas the uppercase letters represents the angles. So if we have a squared in front, which represents a side, we will then use the cos of a, which represents the angle on the right hand side. If we are trying to work out an angle, we use the following formula. Cos of a is equal to b squared plus c squared minus a squared over 2bc. Number 3, the sine rule. We use the sine rule if we know 2 angles and a side opposite one of the angles, or 2 sides and an angle opposite one of the sides. In any triangle ABC, there are 2 different ways that we can actually work these out. So there's 2 different formulas that you can use. The first one has all of the sides at the top in the numerators with their corresponding angles at the bottom. So a over sine A is equal to b over sine B, which is also equal to c over sine C. Or we have the angles at the top and the sides at the bottom. So we can say sine A over A is equal to sine B over B, which is also equal to sine C over C. Number 4 is the area rule. We use the area rule if we know 2 sides and the included angle, and if we need to give the area. In any triangle ABC, the area of triangle ABC is equal to a half AB times sine C. Let's look at our first example. We have a quadrilateral PTSR with diagonal RT. PR is equal to 16 units, PT is equal to 14 units, and RS is equal to 22 units. We are also given the angle of P, which is equal to 102 degrees, and the angle of RTS, which is equal to 65 degrees. Let's see how our diagram actually looks. Please note, whenever you are given a diagram, please draw it in your book. As you are progressing through the questions, you need to make the adjustments on your quadrilateral and fill in the sides that you are actually calculating. Number 1. Calculate the length of RT. As you can see, I've highlighted RT in red, just to show you that that is the side that we are actually trying to work out. Again, let's look at what we can actually use to solve the length of RT. We are given two sides and an included angle. Therefore, we can use the cosine rule to determine the length of the third side. Our equation therefore becomes RT squared is equal to 16 squared plus 14 squared minus 2 times 16 times 14 times cos of 102 degrees. RT squared is therefore equal to 545,14. Therefore, RT is equal to 23,3 units. It's very important that you actually write units there because they did not give us a measurement. Let's look at number 2. Number 2's question states, determine the size of angle S given that angle S is an acute angle. We just worked out the length of RT. Now remember, the small letters represent the sides, and in this case, the small letter S is represented by RT, which we have worked out as 23,3. Therefore, we now know 3 of the elements of the angle RTS. Therefore, we can determine the size of angle S using the sine rule. If we substitute our values in, we have sine S over 23,3 is equal to sine 65 degrees over 22. In this situation, we are cross multiplying and trying to get sine S on its own. So we are then left with sine S is equal to 23,3 times sine of 65 degrees divided by 22. Sine S is therefore equal to 0.95986, and we are trying to work out the angle. So we shift the answer and we have angle S, which is equal to 73,7 degrees. Number 3 states, calculate the area of triangle RTS. To calculate the area of the triangle, we need to know the length of two sides and the side of the included angle. We have RT, which is equal to 23,3, and RS, which is equal to 22. So we can work out the included angle of R. This is the way that your diagram should now look. And we are focusing specifically on the triangle RTS. To work out the angle R, we have to first work out what angle R is, and we can use the rules of a triangle. So all the angles in a triangle equal to 180 degrees. Therefore, 180 degrees minus 65 degrees minus 73,7 degrees is equal to R, which is 41,3 degrees. Now that we have that, we can use the area rule. The area of triangle RTS is equal to a half times 22 times 23,3 times sine of 41,3 degrees. Therefore, the area of RTS is equal to 169,2 units squared. It's important to remember whenever we are dealing with area, we have to square our units. Now it's your turn. Please complete exercise 7.1 on page number 139 and please complete questions 1 through 9. Thank you for watching.